A very warm welcome to all of you. First of all, thank you very much for showing the interest. I'm not sure if all the participants who have shown the interest, if they would join, there is possibility that we'll go more than our threshold of this meeting. So this is 500, and then I have showed emails more than 500, assuming that few of the participants would not join because of time issue. And I hope that will remain true till the end of this meeting. So again, this is our effort to discuss 62443, the specific standard for industrial automation and control system. The objective of this bootcamp is to give you an overview of what the standard is, how you can utilize this standard for uh, security in your operational technology environment, and what are the different sections, how to read them, and how to use them. If we have to discuss this standard in detail, it will take at least a week's time to give you a entire understanding. I had done my 62443 certifications back in 2020, and I still keep on reading the standard. And every time I read this, I always discover a new thing. It's very, very vast, very expensive, and new sections are getting added every year now. In fact, the previous sections that have been already finalized, they are also under reviews. Like last week, I have posted a screenshot of different sections being developed now, and some of the comments were like, which of these sections are under board, which of these sections are published, which other sections are still under development. So that's the status of this standard. It's a live document. Continuously there are upgrades. Continuously there are changes. And our effort during this bootcamp is to give you a working knowledge of 62443, which can help you either in the role that you're working or maybe your career transition into OT security. That's our objective. So having said that, today we are going to give you an introduction about myself and Manju. Then we'll be discussing the cybersecurity life cycle, the challenges in OT security, overview of 62443. We will discuss the key terminology and concepts to read the standard, the foundation of the standard like zones and conduits, and finally we'll end our day with risk assessment, which is the largest section of the discussion today. I know this is one of the most required topics, so we have put up the most time of today's discussion into the risk assessment part. Finally, at the end, we'll be taking your questions to answer to the best of our knowledge. Having said that, this is myself and Manju. I'm having more than 16 years of experience in cybersecurity. Currently, I'm working with Siemens Corporate Technology Research Department. And earlier, I used to work with Government of India. So last 15 plus years, I'm working for security of critical information infrastructures. Earlier, with my role with the government, I used to work for NCIPC in India. Now, working with Siemens. I hold bunch of certifications like IEC 62443 Cybersecurity Expert, CISSP, Sense Grid, ISMS Lead Auditor, and also the basic cybersecurity certifications like Certified Ethical Hacker. Yeah, so with this experience, I hope I will be giving you all a value addition into your OT security knowledge. Now I'll ask Manju to quickly introduce himself.
Hi everyone. Good afternoon, good morning, good evening for somebody. Yeah, first of all, thanks for participating in this boot camp. Surely, first of all, thanks Shiv for this initiative. We always thought that it should be a part of our OT security huddle. Then we were getting many calls and messages on LinkedIn saying that they want to understand about 62443. As you all know that it is usually if we start talking about 62443, it's a marathon. So you really need patience and many documents to read. There are many standards that you need to follow. Unless you start working on these standards, it's difficult to get the real knowledge about 62443. Yeah, coming to my introduction, my name is Manjunath Hiregange. I have total 16 years of experience in industrial automation and cybersecurity. So I started my career way back in 2008 with Yokogawa and as an automation engineer. So I used to have, my experience actually started with the application programming for the PLCs and DCS and all such things. And then, I have involved with entire project life cycle of any automation projects. So throughout my career, later I got an opportunity to be, in the initial, maybe after some 8 years of experience, I started working as an hardware engineer. So there I got an opportunity to start my career towards OT security. I would say started with networking and then slowly jump into 62443. Even even my career also supported that once I completed my 62443 certification. So it's glad that I got the opportunity to work on these standards. Yeah. So and last year I have completed GICSP as well. So it's it was a great opportunity for me to enhance my skills through these certifications. Really, there are a lot many things to do for towards community. Yeah, happy to help along with Shiv. Thanks, Shiv. Over to you.
Thanks, Manju, and I would again thank you for your effort in preparation and also agreeing to support this with the time. Before I move further, I was seeing the messages and then there is a complaint that my audio is not clear. I changed my mic. Could you please send in the message box whether it is clear now or I still need to change my mic?
Shiv, I think, yeah, it's audible now.
Okay.
Yeah.
Okay, that's better. So that's great. So I'm not at my usual location and my usual setup. I'm trying to be more, salvaging the equipments that I have here. But yeah, we'll try to do our best. Okay. So just one more shout out for this event. So when I put up this event, I reach out to a bunch of cybersecurity thought leaders for supporting this event through either the Zoom accounts or through certification to put more structure into this event. And I was happily supported by UJTI Professor Farooq Qazi. He might join today or maybe tomorrow. Definitely, I'll ask him to give and feedback about this session. And also, I would like to thank Cybersecurity India for supporting this event with their resources. Without their support, this would have been a little bit more difficult for us to organize this. So first thing, I will now discuss cybersecurity lifecycle and challenges into OT-ICS. It makes sense before we actually get into this standard to first discuss what are the problems that we are trying to address with this particular standard. So as we know, OT is different from IT. In IT world, which is your laptops, your mobile phones, or your servers, your SaaS cloud, you basically process data, which is the core of it. Most of the time, the services are centralized, standardized. You will be able to use them across the globe. The same service that you are using in India, you would be using the same service in different parts of the world. On the other side, the OT systems are designed to control physical processes and operations for either manufacturing or critical infrastructures, so on and so forth. Every single plant that you visit, their infrastructure is different from the other plant. The ICS system that you will use for a steel manufacturing plant would be different for an automotive plant. And within the same organization, like the steel manufacturing plant, there would be n number of different versions of ICS available. This induces complexity. Their systems are more distributed compared to your IT systems. Like imagine the span of a steel manufacturing plant, there would be n number of different units that are processing different stages of steel melting to steel casting to maybe rolling the sheet. All of these plants have different requirements and they have a distributed architecture or network over there. So OT basically is a mixture of hardware, software, and supervisory control systems designed to basically control the physical processes. It includes sensors and actuators to sense this. It also has something called a programmable logic controller, which will control the physical processes. They will first read through the sensors and the actuators will take the action on it. There will be human machine interfaces, HMIs, and then at the top of it, there will be supervisory control and data acquisition system. These are the four building blocks of an operational technology environment. This is just an overview of OT before we actually get into the security part. Now, having said that, the focus of security is also different in the OT side of the world. When you talk about IT security, typically your focus is to make your data only available to you, which is otherwise also known as confidentiality of data. Then you would ensure that the data that is available to you is also not altered, it is in the original form. Basically means the integrity of the data. The third one then is the availability of data. It is available to the people who requires it for further processing. Whereas when you move from the IT side to OT side, your focus entirely changes to first on safety, then availability of infrastructure. When you have availability, you also want the system is functioning the way it was designed, and confidentiality is the last concerns amongst the the cybersecurity goals. Safety is first because if the system that is controlling physical processes and machines goes haywire, it could have life-threatening consequences. You must be knowing about an incident which happened in 1984 in India. The Union Carbide factories methane isocyanate gas leakage actually caused death of several thousand people. The city is still experiencing the impact on the newborn babies. After this particular incident, the industrial control systems have been changed in their focus, and safety is now very, very integrated to them. But in the past, the recent cybersecurity attacks, they have revealed that even though safety is your fallback system, the cyber attacks can also compromise your safety integrated system, otherwise also known as SIS. Availability is next. You want your plant to be producing the machines or the product that you are producing, or your critical infrastructure should be providing the service they are designed for. Integrity ensures that they are doing the job which is supposed to be done, and finally, confidentiality of data to ensure that information is available for further processing. There is a bit more difference and challenges. IT security, as we know, the focus is confidentiality, OT is safety and availability. There are life cycle challenges. IT side of the world, typically the refresh is within 3 to 5 years. You change your laptops, you change your mobiles. But in OT side of the world, the refresh is typically done in 10 to 25 years. In one particular plant, if you visit and if there are different generations, you will still see Windows XP running, Windows 7 running alongside Windows 10 and 11 as well. The software refresh in the IT world happens as a force measure. Windows will release new software. And if you want the security, since your systems are connected, you will be forced to upgrade it. Organization will decide that now the Windows 10 is baseline for us, and they will upgrade the entire system. Whereas in the OT side of the world, the general philosophy is not force majeure, but don't fix if it's not broken. When we visit to plant and when we design the architect, the typical question is that you are changing my network. I understand that you want monitoring and management, those operational benefits are there. But when you change, there is no guarantee the previous generation of the system will work or not. So we don't want to change the previous systems. We want to take your suggestions, but maybe in the new generation or the new installations or maybe new upgrade, we will consider that. Security softwares, there are high number of security software available. Endpoint security, if you see, and numbers of vendors are available. Whereas in the OT side of the world, there are very less number of vendors who provide you security of endpoints. There need to be due testing of compatibility with different level of systems. Then heterogeneity, IT side of the world, very low. You will see either 2 generations of OS or maximum to 3 of different level of maturity in organization. Whereas in
OT, as I mentioned, there will be n number of generations available. Windows 90, XP is to Windows 11. Protection concept is, as I explained, that it is case-to-case basis, whereas in IT world, it's typically a standard top-down approach. The management and the CISO office will decide what is their policy for security, and then it will propose it to all the employees working at different locations. So how do you address the OT security?
Shiv, sorry to interrupt in between. I think few people are saying it's noisy. Is it possible for you to connect directly through your laptop or some kind of headphone? Or
yeah, I'm connected to my phone. Let me just
change it. How about now? Is it any better?
Yeah, for me it's better. I think for others, I'm not sure. Yeah, I'm saying that it's clear. Yeah, we can continue. Thank you.
Okay, so yeah, let's continue with this one. I'll also try to be a bit closer to my system now. So first thing is to avoid discarding all the IT security technologies. You need to start with those technologies, and then you need to adapt those technologies for your OT environment. That's the baseline. We are not going to reinvent the wheel. We'll be using the existing proven security technologies from the IT world adopted into OT world. You take example of Active Directory Domain Controller. It's a standard in the IT world. Now slowly the OT world is adopting for role-based access control. We will also try to use the IT technologies in terms of the protocol specifications, the communication specifications like TCP/IP stack is now very well prevalent. The erstwhile serial protocols now moving to the Ethernet protocols, and the same protocol stack of TCP/IP is being used. The IT policies, they can be effective in OT, and in fact, the 27001 ISMS, which was the baseline for policies and procedures when 62443 was designed, the cybersecurity management system, which is the part of the standard 2-1, was adopted more than 90% of 27001 cybersecurity management system. There is a slight caveat that the IT environment generally focuses on the security, and we need to be careful about our safety aspects as well. So when we implement the security should not be an overkill for your safety requirements. One of the example, these kinds of examples are also discussed in the standard, but one example is, let's say there is a safety critical systems, and then you want a high level of security with a complex username password. Though it will induce more effort for an attacker, but it will also induce more effort for the operator as well. In safety critical systems, high level of access control and complex access control are more advised because they could be safety critical, and they are compensating countermeasures like CCTV cameras, shift registers, or physical security. We need to develop a clear understanding that how the assumptions and the needs of IECS are different from the IT environment. We also need to be proactive in terms of identifying the differences between the IT and OT security. And at the last, we need to prioritize the safety, availability, integrity, and last confidentiality over the traditional CIA model. So I've been talking about IECS. So far, you must have heard about ICS and OT, how it is different. It is very important to understand because 62443 has preferred IECS over ICS. ICS in general basically means the control systems acting together to achieve an industrial operation or objective. Whereas industrial automation and control system is a collection of personnel, hardware, software, and policies coming together for the operation of industrial processes. It can affect and influence the safety, security, and reliability of the operation. So you see, the importance of the key personnel has given a lot of weightage in IECS. With the experience in the automation technology, it is well understood that the people or the operator, they have intangible knowledge, and it needs to be identified and documented what are these key personnel in the plant and how you would ensure that their availability is there for the operation of the particular ICS system. Moving to the IEC cybersecurity life cycle, there are three phases. The entire standards revolves around these three different phases. First one is the assess, second is develop and implement, and third one is maintain. It's different from your other standards, like you have in 27001, you have PDCA, Plan, Do, Check, Act. In NIST cybersecurity framework, you have identify, protect, detect, respond, and recover. But in 62443, there are three different phases. In the first assessment phase, you will identify what are your assets, what are the critical things, how you will secure it with something called as security level targets or SLTs. In develop and implement part, you will put security countermeasures to meet your target of security level. And last but not the least, in the maintenance phase, you will ensure that your risk is managed and your target security level is always met. Either it is higher or it is at least at your desired level. Okay, so seems like there is some broken image which is not loading. Okay, so now getting into the 62443 standard. This is the currently approved series of 62443 standard. I have put a star here, and this star has a significance which you will see in the coming slide. But if you have to interpret this standard, there are four different tiers. First one is general, then policies and procedures, and systems and component. If you have to see what all these tiers means, general tier basically comprises the broad scope of standard and the different reports. 62443 is basically a mixture of standards and technical reports. Then you have policies and procedure tier. It targets on the people and procedural aspect of the cybersecurity. As you know, there are three pillars when you are designing the security. These are people, processes, and technology. The 2-1 part of the standard primarily for this tier 2 of the standard primarily focuses on the people and processes part. Then system tier, which concentrates heavily on the technological element of security. And finally, the component tier, it deals with security related technical requirement for product development and the product itself. These are the four tiers approved by ISA. Now there are two more tiers I have added. These are new developments. Currently, you don't see in the previous image, but there is another image that I have put up for your understanding. There is one called profile tier, which basically talks about the implementation of standard for different sector. The first one that is under development is the profile for energy sector, since energy sector is the mother of all the critical infrastructures. So it was put the first focus on. Then there are evaluation tier, which measures the effectiveness of a particular section of the standard, like evaluation criteria of 2-4 part of the standard, which is for the service providers. So there are currently 6 different tiers in the standard, but ISA 99 currently recognizes 4 tiers only. Okay, so as I mentioned, this standard is, the series is basically a mixture of standards and technical reports. There is a specific section in the standard in the tier 1, which talks about all the definitions and glossary. It is the part technical report 62443-1-2. When you read this standard, whenever you see something called as TR, it basically means a technical report. Each of the part of the standard, there is a specific paragraph 3, that talks about the terms, definition, abbreviation, and acronyms adopted from 1-2 part of the standard. So throughout this entire series, these definitions will remain same, whichever part you are using in the standard. This is one example from the 1-1, which is about the terminology, concepts, and models. And as you can see, the paragraph 3 talks about terms, definitions, and abbreviations. This is the standard structure for all the different parts of 62443. You will always find this structure. First one being the scope, second one being the normative references, third one being the terms, definition, and abbreviations. The section 4 and 5 will change based on the particular sections of the standard. Now, this is the new one, that is the recent one. In the previous one, you have seen that in the general category, there are only till 1-4, but now there is 1-5 also, which is already published last year. It talks about the scheme for 62443 cybersecurity profile. That basically defines how you would use 62443 for different sectors. So currently in this one, we will be talking about this particular standard tomorrow. What is the definition given? And according to these definitions, whatever profile you'll add, they will be added in this particular section 5-dash series. Then there is another one, 1-6. It is currently under vote, which is application of 62443 for IIoT. In the evaluation side, there is already one published version, 6-1, which is security evaluation methodology according to 2-4. 2-4 is the cybersecurity program requirement for IEC service provider. Then there is one more, 6-2, currently being developed. It is security evaluation methodology for 62443-4-2. Basically, when you are doing a product level security, how would you actually evaluate that security compliance? It is being given into 6-2. This is the key of this standard, which you can see there are different parts, either developed or under development. Some of them are under revision. Some of them are actually put up for vote. Like 2-1, there is a revision which is already approved. It is due for publication. So if you have to correlate with your previous understanding of ISMS, this particular part 2-1 is exactly similar to your 27001 2013 version. There are slight changes if you compare to 2022 version. Then there would be system level security, component level security. Tomorrow we'll be discussing 3-3 part and 4-2 part as well. Today we will be focusing on 3-1, 3-2 for the risk assessment. Again, tomorrow we'll focus on patch management, 4-1 for security lifecycle, and bit of your cybersecurity profiles according to 1-5. Now we'll get into key terminology and concepts. These terminologies are very important to understand this standard. The first one is about defense in depth. As you all know, it is a borrowed concept from the erstwhile palaces or forts developed by the kingdoms and the chieftains, that they would have different concentrations of their armies to protect their fort or their stronghold, which can also be correlated with your crown jewels. I have a specific slide on this. Foundational requirement is specific to 3-3 and 4-2 part of the standard. We'll see that one. Security levels, maturity levels, these are all part of the standard. Threat, vulnerability, and consequence we will be discussing in the risk assessment part. And then cybersecurity program is part of your CSMS. We'll be discussing specifically this particular part. Policy procedures are those part which address your people and process part of security. Zones and conduits is the key concept in 62443, which basically tells how you will be dividing your overall architecture to make appropriate security level. So this is one architecture that we have taken from Science Organization. You see these are different concentric rings. The core of the ring is basically a device. Then you have your protocols, and over it there will be applications. Outside the application, there will be asset, then your network segmentation, your perimeter defense, your physical security, and at the outer layer, policies and procedure. So basically, there would be circle after circle of security that will be implemented. And in the standard, this core concept is utilized. This is also reflected in the designing of the standard. You see, there is first we have defined the different key terminologies and components of the standard. Then we jumped into policies and procedures, which talks about our cybersecurity program. Then we go at the system level security, and finally we go at the component level security. So this is also the defense in depth style of the standard. We know that single defense is weak. We don't want single point of failure, and that is why a layered approach is being used, so that if one of these cybersecurity control fails, there are other control that could be used for securing the infrastructure. It's a stepwise manner. So one after another, you'll be putting the security and different consent. The benefit is it will induce difficulty for the attacker. It will mitigate weakness of one tier, since you have security over one particular layer through a different layer that you put around it. It will also improve your overall security postures. You can also correlate with your home, that you will be putting windows and locks, and when you are living in your apartments, most of the time you will be putting a grill outside your apartment door. That is your defense in depth concept, that you want to ensure if your wooden door is weak, then you would like to put a steel door outside it to ensure that there is a double layer of protection. The same concept is followed in cybersecurity as well. Then there are security levels. The security levels are designed specifically for measuring the technology aspect of cybersecurity. So it basically tells, if you see the adversarial perspective, that who could be targeting my infrastructure, based on those understanding and the adversary perspective, or you can also correlate with the risk perspective, you will be implementing the security. If you see that your protection is for some casual or coincidental violations, maybe your insiders, or maybe some careless employees or some contractors, or maybe your information available on Shodan, your PLC is connected to a internet connected system. Those kind of risk, if you want to control, then the technology that would be required should be compliant to security level 1. If you want to protect from professional attackers, which is having a little bit more understanding of technology, they are having more resources, their motivation is generally low, they are not doing a targeted attack, but they can go to Shodan, find out the PLC connected to internet. Sometimes Shodan will also tell them the vulnerabilities, and they will try to attack the infrastructure. Then you would need a security level 2 protection. If you want to secure your infrastructure from cyber criminals, your competitors, then group of hackers coming together, where there's moderate motivation, like they want to earn money out of it, or maybe they are motivated with some different grudge or competition, then you would basically put security level 3. And at the top of it is security level 4, which is the highest level of security, where you want to protect your infrastructure from nation states or government organization or highly motivated skilled attackers coming together. Since there is no limit of resources when somebody targeting you at the highest level, practically saying security level 4 is just a theoretical concept. If somebody or some nation actually targets an infrastructure, then there is no way we can protect that particular infrastructure. These are four security levels for measuring your technological part of security. These 4 security levels in 62443 are also divided into 3 different types. The first one is target security level, which basically tells your desired level of security for a specific system or a component or a product. It typically is established by conducting risk assessment of that particular system and identifying the necessary security level. Then we have capability security level. It tells the capability of technological security either for a system or a product itself. The third one is the achieved security level. So when you put the target around it, and after implementing the security, you check whether you are meeting your target. The security level that you will be getting is called achieved security level. We will be using these terms in our risk assessment discussions, in our 3-3 part discussions and 4-2 part discussion. So it makes sense to have the basic understanding of what security levels are. Then we have maturity levels. Security levels are used to measure the technology, but when you want to measure the people and process part, you can't use security levels. You need to use the maturity level. Why so? Because maturity levels basically tells that how repeatable and consistent your process is, how mature your human resources are in terms of understanding the system, in terms of being agile. When there is an incident, they can quickly scramble and then respond to the event. All of this can only be done through the understanding of the processes, conducting the drills, documenting it, and then getting known to the people who are critical in the organization. The maturity level in 62443, they are similar to capability maturity models, CMMI model, but instead of 5, there are 4. Level 4 and 5 are combined and merged into maturity level 4 in 62443. The specific part of the standard which relate to processes is 2-1, your overall cybersecurity program, 2-2, 2-4, and 4-1. All these 4 parts of the standards use maturity model, maturity levels, whereas security levels were used by 3-3 and 4-2 part of the standard. Now, there is one more concept called foundational requirement of security. Since we have seen in the beginning, the focus of security in industrial control system is not CIA, it's availability, integrity, and confidentiality. Now, to gauge these 3 different areas, they have been divided into 7 foundational requirements. These are called FRs, and FR1 is basically identification and authentication controls. All of them, as you can read, are basically security controls, and you can consider them as the pillars of security for industrial automation and control system according to 62443. IEC foundational requirement will regulate access to particular device and the information. It will also provide you the capability to evade the unauthorized access to a device. Whereas use control, FR2, will help you manage the use of a specific device and information, how you want to use it. It will also prevent unauthorized use of the information. The confidentiality controls are typically part of your FR2. Then we have system integrity. It helps you maintain data integrity across different communication channels. It will also seal unauthorized modification of data when data is in transit. FR4 is data confidentiality, your encryption controls over these communication channels. Fifth one is restrict data flow to limit the information to the communication channels and also avoid unauthorized disclosure of information. Then we have foundational requirement 6, timely response to event. It is the capability of the systems to detect when there is an incident and also the capability to have these records available to do forensic analysis. Last but not the least is the resource availability. It actually guarantees that your network is accessible and will also protect against denial of service. So all the technological security requirements divided into 7 foundational requirements. We will talk more about these when we discuss 3-3 and 4-2 tomorrow.
On the left side, can we show again the safety is on the top?
Yeah. Thanks, Daniel, for adding. I think we have discussed safety in the first slide. But yeah, that's a very good point.
Thank you.
Then we'll discuss a bit about different roles there are and the parties involved in overall IEC security. There are asset owners who own the system, and they are responsible and accountable for maintaining the industrial automation control system. There are maintenance providers. They will maintain the infrastructure. They could be your service providers, MSPs. There are automation solution providers, sometimes also called as system integrators. They will design, implement the secure automation solution, and they will also integrate the security considerations throughout the development of the solution. At the bottom of it is the original equipment manufacturers. Sometimes the OEM themselves will also play the role of system integrators. But since different automations have different needs, typically there are two different entities involved. Or if there is an OEM trying to be a system integrator, they might also use product from different OEMs as well. Since there is a lot of customization happens, so this is hardly possible that a single OEM will provide the entire solution. But they have different roles, and to understand that, this is the overall security program for life cycle. And at the bottom, you see each of these parties involved, they have their specific roles, and 62443 have a specific standard dedicated to those different roles and responsibility. If you see the specification, it is the responsibility of asset owner and system integrator, and 62443 2-1, 2-4, and 3-2 are the part of standard that you will refer for. Then design is being done by asset owner, your product supplier, as well as system integrator. You will refer 2-1 for cybersecurity program, 2-4 for security requirement of service provider, 3-2 for risk assessment, and 3-3 for your security requirement for the system. So across the overall life cycle, the standard is effective, and you would see that 2-1 is continuously constant. Why so? Because 2-1 of the standard is cybersecurity management system, and you're required to manage the overall cybersecurity of the system throughout the life cycle. Policies and procedures are also the foundational framework. It helps in securing the overall industrial control system. They are basically organizational rules, the intent of the organization, how they want to manage the security, and it will also have some technical measures to be documented to protect the infrastructures. These documents are not only the specification to manage and protect the system, but they will also define the roles and responsibilities. So it's very important that security, generally in security, the awareness itself is not sufficient. Like the employee can get the information or the awareness online or maybe attending to these forums. But if there are no supporting policies and procedure, it's very difficult to actually manage the security. You need to have awareness of the people, and then you need to have supporting policies and procedures which will enable implementation of technology. Now I'll jump into security zones and conduits. Security zones are basically a logical grouping of physical information and application assets. You can basically see that the bigger umbrella of security requirement, you basically want to divide that into small chunks so that the security is manageable, and neither you are overdoing the security nor you are underdoing the security. That's the basic objective. They will represent the logical division within the ICS network, and typically they are based on functionality and security requirement. You can take an example like a safety integrity system would have a different security level requirement compared to your operational manufacturing zone. Why so? The manufacturing zone would be accessed by a number of people, whereas your safety integrated system is only restricted to few people. So you would put a different level of security for your safety system. Zones are basically created to facilitate network segmentation and enforce the security policies designed according to your cybersecurity management system. Each zone will represent a distinct area or level of trust in ICS. We have discussed 4 different security levels, and according to these security levels, we will divide our entire infrastructure into different zones and conduits. There is a possibility that these different zones would be requiring different security levels. Maybe one of the zones, like let's say manufacturing zones, requires security level 2. Then there's a control zone that requires security level 1. There is an enterprise zone that might require security level 3. And there is a DMG, since it's also going beyond your secure trust boundaries, it might have security level 3 requirement. Each of these infrastructures and assets within these zones would have different adversaries, and that is the reason that you want to have different level of security. Zones also help in terms of segregation of critical systems from less critical systems, and that is why they are called like different zones. The example that I have given from the safety integrated system exactly tells about that, that the criticality of a safety instrumented system is different from your other systems in the environment. Conduits are the communication access. So basically, you have established different areas based on your automation requirement, but these areas would also require to communicate between each other. So how would you ensure that communication is secure? There may be possibility that a less secure area would try to communicate with the highly secure area. And if you don't put up appropriate level of security, the threats can traverse. So that particular communication network addressed as conduits also ensure that the threats from a less secure area does not traverse to a highly secure area. They are the control path or connections between different zones, and they will enable maintaining the desired security level. Typically, the target for conduits will be similar to the highly critical security zones. If you have, let's say, a zone which will require security level 1 versus a zone which requires security level 3, then your conduit will also require security level 3. The assets that
Mr.
will be
Shiv, can
part,
you please disable the chat so that we can, concentrate on your briefing, please?
yeah, sure. Okay, so I have disabled it for some time. We will enable it again. Thanks for pointing that out. So we were talking about conduits. They are basically pipes to connect different zones and enable communication out there. You can imagine them as wirings, routers, switches, network management devices that make up the entire communication infrastructure. Conduits are used to analyze the threats and vulnerabilities also at the zone boundaries. So you will put systems like IDS or IPS or anomaly detection solutions so that when the threats are traversing between these networks, you are able to measure them. So these are two examples of zones and conduit models. The first one basically have different SCADA system, different zones, and the other one is basically talks about separate SCADA zones coming together. You may imagine that there is a plant and the plant have different functions. I can take the same example of a metal producer plant. There would be requirement of, let's say, transporting the raw material through conveyor belts. So these conveyor belts would require automation to be controlled. So that could be your one particular plant. You can call it as a plant which will control these equipments in the conveyor belt. Then the conveyor belt will transport this to one particular plant that might be your blast furnace. So blast furnace itself will become one of the plant. After the blast furnace, then there would be a let's say sheet metal plant is there. That will become your another plant. Each of these plants would have their own control zones and their plant zones, and then you can segregate their plant zone and control zones into two different zones based on their criticality. Whereas in the second example, you can correlate it with something like your power grid. You have different substations, all of these substations connected to a grid, and then the grid will take decision how to distribute the power and how they will manage the overall level of security for different areas. So based on your requirement, you can segregate differently. This is the enterprise model from the first model that you discussed. What you are seeing in the red is basically the conduits enabling your connectivity of different plant to an enterprise network.